Hello, in this lecture we're going to continue with the discussion of Perfect Competition Chapter 13. Remember that our objectives are to explain how perfect competition serves as a reference point, explain why producing an output at which marginal cost equals price maximizes total profit for a perfect competitor, determine the output and profit of a perfect competitor graphically and numerically, and explain the adjustment process from short-run equilibrium to long-run equilibrium. So remember where we are at from last time. We're discussing areas where there is perfect competition. Now, perfect competition is an ideal. No firm or industry is actually perfectly in perfect competition. However, it's a good starting point. It's a good reference point so that we can make the simplest graph that can tell us the most information by isolating the most factors and then take into consideration particular markets which will be more or less in alignment with perfect competition. So within perfect competition, we're going to have price takers. There's no barriers to entries, and we have goods and services that are homogeneous. They're the same in this model. So we're going to have this idea. We got a nice little table over here again, which is very nice. The profit maximizing condition of a competitive firm is where the marginal cost equals the marginal revenue equals the price. So remember, all that means is that when we talk about the marginal cost, we're talking about the cost of basically the next unit that we're going to make on the margin. Marginal revenue equals the next unit of revenue that we're going to make on the margin. And of course, we're going to produce where those things are equal. Now, why is it going to equal price? Because as we stated before, marginal revenue equals price. Why? Because we're price takers. When we enter the market, when one individual firm enters a market that is in perfect competition, they have no choice about price. They have to produce the price that is the market price because they cannot differentiate themselves in that particular market. Therefore, if we can simplify our table then by knowing that, meaning that price equals marginal revenue, and notice it's the same all the way down, it's $35 because we are price takers in this case. So all we're going to take a look at in this table is the quantity and look at the marginal cost. So if we have 0 and then we moved to 1, notice it's skipping a column here. We're not looking at the total quantity. We're just looking at the change, the marginal cost. The marginal cost is going to go from 0 apparently up to 28, which means that there's a change of course, 28. And then if we went from 1 unit to 2 units, the cost went up again, and the change in cost, so it went from 28 apparently to 48, which is going to be a change or a difference of 20. So the change in cost went from 28, and now the change in cost is actually going down. So for us to produce that 1 unit, it cost us $28, and for us to produce 1 more unit, go from 1 to 2 units, it only costs us an additional 20 units. So this is not the total cost, this is the marginal cost. Then when we go from 2 units to 3 units, it costs us an additional $16. So note the cost is going down. The marginal cost per unit is going down. Then when we go to 4 units, it costs $14. Once again, the marginal cost is going down. It's being cheaper for us to produce more at this point. And then once again, we're producing 5 units. The marginal cost goes down to 12. It's still getting cheaper. Note that what happens when we go to 6 units, the marginal cost, the cost of us to produce another unit, is now $17. So it went actually up at this point. We do expect that to happen because at some point, we're going to have diminishing returns. So when we produce more units, we're going to actually be less efficient at some point. That's the general rule. But of course, the marginal cost is still less than the marginal revenue. Therefore, we're going to produce another one. We're going to go to 7 units here. And we got the 7 units goes up to 22. But again, we're still below the 35. So when we think about producing another one on the margin, probably gonna think about that. We're going to say, okay, if we produce another one, we're at 8. That brings us up to a marginal cost. It costs us $30 to make that next unit. The marginal revenue is $35, so we still made $5. Now, should we make the next unit? And of course, marginal revenue doesn't quite equal marginal cost here because it's 30 and 35. However, if we make the next unit, we're going to jump up to a marginal cost of 40 and marginal cost of 40, right, and a marginal revenue of 35. And therefore, we're not going to produce that next unit. So somewhere in between here, of course, is where marginal revenue equals marginal cost. We're going to stop at that 30 marginal cost, which is 8 units, because if we produce another one, it's going to cost us more on the margin to do so. So if we looked at that graphically, then we would see a graph like this. Notice we've got, of course, the P on the y-axis, the Q on the x-axis, and you'll note here that we have the straight line at $35. That was the price, which also equals demand, which also equals marginal revenue. Why? Because we're representing a particular firm that is going into the market, and they are in a perfectly competitive market. So that means they can't differentiate. They cannot do anything except just sell the product for that price because they're going into a perfectly competitive market. Therefore, we have the straight line at 35, and then we have our marginal cost in graph form in this case. So if we are anywhere up here in this section, we then have marginal cost, of course, that is greater than the price or the marginal revenue. Therefore, we need to decrease the output to increase the total profit. Why? Because any unit that we're producing up here, if we're producing another unit, every unit we make, it's costing us more in marginal cost. The next unit's costing us more than the price it costs to produce it, $35. So if we're producing up here, then we would be better off by producing less. We want to produce less because every unit we're producing above this $35 line is costing us more than it does to produce it, so we want to produce less of it. On the other hand, of course, anytime we're down here, we want to produce more. So if we're down here, the price that we're receiving is costing, we're getting more marginal revenue than we are in marginal cost. We want to produce more, and so we're going to keep producing more, of course, until we hit this point here where marginal cost equals price at 8 units. Total profit is maximized. So that is our maximizing area. You might be saying, hey, you know, that profit equals demand equals marginal revenue looks like it could mirror, say, a demand curve, and we can say that the marginal cost looks a lot like a supply curve, and in essence that's the case here. So the marginal cost curve is the supply curve. So because the marginal cost curve tells us how much of a good a firm will supply at a given price, the marginal cost curve is the firm's supply curve. So note what we're talking about here is the firm's supply curve is the marginal cost curve. We're not talking about the market, we're just talking about that individual firm. Therefore, for example, if market price is $19.50, the firm produces 6 units, as we can see here. And obviously, normally, if we want to see it just as a normal kind of supply curve, we would probably cut it off here and not have this area. We would basically start it as an upward sloping supply curve. That's our normal view of the supply curve.